What in the world could possibly connect a Baroque composer, a 20th century artist, and a logician who completely shook up mathematics? Well, it turns out they were all chasing the same beautiful, paradoxical idea, a hidden thread that weaves them all together into what you might call an eternal golden braid.
So, here's our game plan. We're going to start in the court of a Prussian king. Then we'll jump over to the impossible worlds of MC Escher. After that, we dive headfirst into a really profound mathematical truth. And finally, we'll tie all three of these strands together.
All right, so our story kicks off in a palace in Potsdam, way back in 1747. It's all about a king who was obsessed with music and a composer who was, well, an absolute legend.
So picture this. It's a May evening, and King Frederick the Great of Prussia is about to start his nightly concert. Suddenly, an officer hands him a list of new arrivals. He scans the names, puts down his flute, and with this big jolt of excitement, he tells his whole court that the legendary Johann Sebastian Bach had just arrived.
Now, the king was really excited to show off his brand new instruments, these things called pianofortes, and he wanted to test the skills of the 62-year-old Bach. So he plays this really complex, tricky musical theme and challenges Bach to improvise a 3-part fugue right there on the spot. Bach, of course, nails it. But then the king ups the ante, asking for something almost impossibly difficult, a 6-part fugue.
So what makes that so hard? Well, first you got to understand what a fugue is. Think of it less like a simple song and more like a really sophisticated conversation in music. One voice introduces an idea, a theme, and then the other voices pick it up, weaving in and out, building on it, all while staying in perfect harmony. It's complex.
And then there's an even stricter form called a canon, which is really more like a puzzle. You know the song Row, Row, Row Your Boat? That's basically a canon. It's a single melody that harmonizes perfectly with delayed copies of itself. Most melodies would just sound like a total train wreck if you tried that, but a canon is built to work against itself perfectly.
So Bach couldn't just improvise that 6-part fugue right then and there. The king's theme was just too weird, but he didn't forget about it. He went home, took that royal theme, and just went to town, composing this masterpiece called the Musical Offering. He sent it to the king, and it had not 1, but 2 fugues and 10 incredibly clever canons.
But tucked away inside this collection, one of these canons does something that seems like it should be totally impossible. It feels like it breaks the rules of music by climbing up and up forever in a perfect, self-contained loop.
So how does this actually work? Well, the music starts in one key, let's say C minor. But by the time the theme is over, it has smoothly shifted into a new key, a step higher. This new ending then loops perfectly back to the beginning, but now the whole thing is in that new, higher key. You do this 6 times, and like magic, it ends up back in C minor, but a full octave higher, ready to start its climb all over again, forever. It's a perfect, endless loop for your ears.
Okay, so Bach created this auditory illusion of a staircase that never ends. Fast forward 200 years, and an artist is about to create its perfect visual twin.
I'm sure you've all seen the work of MC Escher, right? His mind-bending drawings that just play with your perception of reality. But his stuff isn't just about cool tricks. He's exploring these really deep ideas about structure and infinity.
And this is where it gets really fascinating. Look at the parallel here. Escher's famous waterfall lithograph creates this 6-step visual loop where water seems to power itself, falling endlessly. That's just like Bach's canon, which creates a 6-step auditory loop that rises endlessly. They're both playing with a hierarchy. For Bach, it's musical pitch. For Escher, it's physical height. It's literally the same theme, just played in 2 different media.
Escher got completely obsessed with this idea. You can see him playing with it, tightening the loop in his work. In ascending and descending, you've got this long loop with tons of steps. Waterfall is a bit tighter, with just 6. He tightens it even more in Drawing Hands, a 2-step loop where each hand is creating the other. And finally, he gets to the tightest possible loop you can have, just 1 step, in Print Gallery, a picture that somehow contains itself.
So we have this amazing looping paradox in music and in art. But believe it or not, its most powerful and startling form shows up in the purest discipline of all, logic and mathematics.
The logical version of this loop starts with a really simple, ancient brain teaser. You've probably heard of it. It's called the liar paradox, and the sentence is just 5 words long. This statement is false. I mean, just think about that for a second. If you assume the sentence is true, well then it has to be false. because that's what it says it is. Okay, but if you assume it's false, then that must mean it's actually true. You're just stuck in this infinite, inescapable logical loop. It just completely breaks the idea that every statement has to be either true or false.
Then, in 1931, this absolute genius of a logician, Kurt Gödel, did something that was just an act of pure brilliance. He took the basic structure of the liar paradox and figured out how to build a version of it using the super rigorous language of math. His sentence didn't say, "This statement is false." Instead, it said something like, "This statement has no proof."
Okay, this is the crucial part, so let's walk through it. Gödel created a mathematical statement, let's call it G, that basically says, I cannot be proven. Now, just think about what that means. If the system of math could prove G, that would mean G is true. But wait, G says it's unprovable. That's a flat-out contradiction. It would break the whole system. So to stay consistent, this system simply cannot prove G. But here's the kicker. If G can't be proven, then what it says about itself is true. So G is a true statement that is unprovable within the system. And that means all of mathematics is fundamentally incomplete. Mind-blowing, right?
All right, we've journeyed through an endless piece of music, an impossible waterfall, and an unprovable mathematical truth. Now it's time to see how these three threads all weave together.
The concept that connects all of these is what the author Douglas Hofstadter famously called a strange loop. A strange loop is what happens anytime you're moving through the levels of some kind of system, like musical keys or physical height or levels of logic, and then somehow you find yourself right back where you started.
And you can see it so clearly here. Bach, Escher, and Gödel, they were all masters of the strange loop, each in their own domain. Bach creates a loop through the hierarchy of musical keys. Escher creates one through the hierarchy of physical space. And Gödel creates a loop in the hierarchy of logic itself, where a statement can actually refer to itself. It's like they are three different shadows all cast by the exact same idea.
And this really matters, because strange loops aren't just neat intellectual puzzles. They point to something fundamental about any complex system, the ability to refer to itself, to look back and even modify its own structure. This might just be the key to understanding some of the most profound things in the universe, like life and even consciousness itself.
In fact, this whole idea is absolutely central to something we're all talking about today, artificial intelligence. You could say that the whole quest for AI is really a quest to create a system of rules that's so sophisticated it can bend back on itself, a system that can watch what it's doing, learn from it, and then rewrite its own rules. That is the ultimate strange loop.
Which really brings us to a final, pretty deep question about the most complex system we know of, our own minds. I mean, if our brain operates on a set of rules, but our consciousness lets us think about and even change those very rules, aren't we the ultimate strange loop? Where does the program end? And where does the self begin?